Hey everybody, this is Mr. Munson. We're in Unit 7, Right Triangles, and this video is going to cover the vocabulary that you will need in order to understand this unit and do well. So let's go ahead and get started. Okay, first up, we're looking at our vocabulary sheet. If you don't have this already, you can certainly stop by and pick one up from me. I'll try to put a link to a copy so you can make your own if you don't have it. But first up is that first section. It says a side of a triangle that helps form one of the angles is called, this can be an adjacent side. So looking at an angle, let's say in a triangle, the sides to this one here, and this one here are called adjacent sides. The one that I didn't mark is called an opposite side, which brings us to the next word. The side of a triangle that is not part of an angle is an opposite side. This side is said to be opposite the angle. So if I'm looking at this angle right here, the side opposite it is this one over here. Now the next one, legs. So the legs pertain to, in a right triangle, the two adjacent sides to the 90. They're the ones that make it up. So there's the legs. We'll call this one leg 1 and leg 2. Next up, hypotenuse. In a right triangle, the hypotenuse is the side opposite the 90. Now the Pythagorean theorem is not a squared plus b squared equals c squared. It's actually a little bit more involved than that. It's if a, b, and c are sides of a right triangle. So we have to start off with the idea that it's a right triangle, where c is the hypotenuse. If that's the case, then we get to assume that when I take the two legs, a and b, and square them and add them together, they'll equal the hypotenuse squared. So if you look just underneath this a squared plus b squared over here, it's basically this. If I have a right triangle, then I know a squared plus b squared equals c squared. Now just underneath it, it's asking me to write the converse of that. So for my logic, I know I'm going to take the main pieces and just move them. So if a squared plus b squared equals c squared, c being the longest, then it must be a right triangle. Now, that moves me into the three bears. The three bears says, look, suppose a squared plus b squared doesn't equal c squared, right? Suppose that the c, when it's squared, is bigger than that sum. Then this implies that it's too big, and it's an obtuse triangle, not a right triangle. And then if you look over here, you'll see that, let me go ahead and write that on the spot over on the right hand side. Sorry about that. That leaves this area over here for it to be blank, and you have to read through it while it's blank and try to figure it and remind yourself what it is. It's a good learning tool, right? So if a squared plus b squared is such that the c squared, the thing I thought was hypotenuse, was too small for that to happen, then it ends up being that it's an acute triangle. And if they equal each other, as I just said, then it must be just right. All right, next up is my special triangle, which has a 30, 60, and 90 in it. The sides would be 1, 2, square roots of 3. And so the reference triangle, this triangle I'm going to memorize and use in lots of problems, those sides go in specific places. A lot of times students put the square root of 3 over on the hypotenuse here. But in reality, square root of 3 is a number like 1.73. 1.73 is less than 2. Since 90 is the largest angle, 2 deserves to be across from the largest angle. So make sure you memorize that. For the special triangle 45, 45, 90, the sides are 1, 1, and square roots of 2. Now these two special triangles are going to be used in the special triangles unit, where when we're given a triangle that has a 30 and 60 in it, then we can draw this one next to it and know that they're similar from last unit, since they both have two angles that are congruent. And since they're similar, then their sides are proportional. I'm going to use proportions to solve for missing sides. All right, next up is a word that I want you to memorize. It's 9 letters long, and it basically is a way of remembering the trig functions that you're going to learn in this this section, in this unit. And so oops, that's an A there. And then you have TOA, so SOHCAHTOA. All right, so your trig function sine is sine. Now watch how I do this next character. I draw a circle, and then I do a little loop. Okay, that word or that symbol right there stands for the word theta. Okay, so I won't write the word theta underneath it in the future, but that helps you understand how to say it. And basically, theta is kind of a holding spot for an unknown angle. Like in the world of most algebra, we use x's and y's for our unknowns. In the world of trig functions, an unknown angle is theta. So that's kind of the x in this world of trig functions. So sine theta is represented by a ratio between two sides in a triangle, in a right triangle. So if I was standing here, I'd have to know that that side there is the opposite side. The side here is the adjacent side. And of course, that side there across from the 90 would be the hypotenuse. Well, whatever sine means, and that's what we'll figure out as we go through this unit, when I'm standing here, sine is made up of the opposite and the hypotenuse side, so whatever numbers those are. So in generic sense, I'm going to write an O and an H there. And later on, we'll be putting numbers there. Let's go on to cosine. Similarly, cosine has a theta in that spot, and it's a representative adjacent over the hypotenuse. Okay. Now, if you're not going to remember what A and H and O and H mean, those are our first words, by the way, in our vocabulary sheets, but you should maybe write out more to it. OPP, ADG, whatever you need to, so you can remember what O and H and A represent here. All right, last, tangent. Tangent is opposite over hypotenuse. Now the inverse trig functions are written like this. So go ahead and write this over here. Sine -1, cosine -1, and tangent -1. So you write those over there so that when you come to the page to study on the left-hand side, you see those and you're trying to figure out what word is it that starts with I that would be related to that. And of course, it's inverse trig functions. Next up. Suppose you had a man standing down the ground and he looked up to the top, but he was first kind of, let's just make a triangle here. He's like this. He looks up to the top of the building. That's called an angle of elevation. The angle of depression is similar to the angle of elevation. You know, let's say the person's looking straight out, and then they look down at some object on the ground. So the person's looking out, and then they look down at that object. That's an angle of depression. Now, I got to tell you, in the past, a lot of students mistake it for being the angle between them looking down and the building. And that's incorrect. It is this one. That's the angle of depression. All right, that's it. Go ahead and if there's some do it problems at the end here, go ahead and have a go at those. Enjoy your day.